Good morning, everyone. We are quite excited to be here at the Global Partner Summit in reInvent to talk to you about AWS Cloud Control API, a new service that we recently announced on September the 30th. Before getting into the discussion, we would love to briefly introduce ourselves. I'm Rahul Sharma, and I'm a Senior Product Manager at AWS. In this talk, we will also be joined by our colleague, Veli Siao, who is a Senior Partner Solutions Architect at AWS. Over the course of today's talk, we will walk you through how you can leverage Cloud Control API to help our mutual customers access the latest AWS innovations faster. So let's dive straight into it. In today's session, we will walk you through the background on Cloud Control API's genesis, introduce what Cloud Control API is and how it benefits your solutions and our mutual customers, walk you through a demo on how to manage cloud resources consistently using Cloud Control API, share partner stories, and conclude with how you can get yourself started. Before we begin the background story of Cloud Control API, we want to first take note of the sequence behind our product development process. At AWS, we work backwards from our customers, hear their feedback, identify a solution, and then start building our product. Cloud Control API was no different. It followed the same set of sequence. In case of Cloud Control API, there are three types of customers that we targeted. First are the developers using AWS Partner Network or APN partner solutions, such as yourselves, to manage and monitor their cloud infrastructure on AWS. Second are APN partners, such as yourself, who build tools on top of AWS and expose those tools, be it infrastructure as code, configuration management, cloud security posture management, among others, to our mutual customers. And finally, builders who build and manage their application infrastructure using a variety of service-specific AWS APIs. We targeted opportunities associated with each of these customer personas. So let's understand what these opportunities are. The first opportunity is that we heard from developers who use a variety of APN partner solutions to manage and monitor their cloud infrastructure that they want to increase their pace of innovation and time to market for their applications. For example, there are situations when there's a lag between supporting a new AWS release in APN partner solutions. For instance, if Amazon Memory DB for Redis resources are unsupported in a partner tool, then our mutual customers will need to wait for its support before they can start using in-memory database solutions. Several customers using APN partner solutions have notified us of this as among the challenges they faced. So the open question for us was, can we help our mutual customers adopt new AWS features and services closer to their launch or on the day of launch? That was opportunity number one. The second opportunity we identified was related to the first one, in fact, in the sense that how can we enable you as our partners to support latest AWS innovation through a one-time integration? And a natural question may arise to you, why is there even a need for this? As you are aware, AWS continues to innovate on behalf of its customers to help them unlock new capabilities on the public cloud. For example, we today support over 200 fully featured services, and in 2020 alone, we launched over 2,700 significant new features. To give you an idea about the scale of innovation, in 2011, AWS had released 80 new significant features, and in 2020 alone, there were over 2,700. That's over a 30x increase in innovation, and this pace continues to increase as we speak. We hear from APN partners that they want to stay in sync with AWS's pace of innovation. And we learned that it can often take a few weeks to integrate with and expose each new AWS capability to our mutual customers. Partners such as HashiCorp, Pulumi, and several others across configuration management, cloud security posture management space have informed us of their need to easily integrate across AWS capabilities. We wanted to find a solution to enable you to stay up to date with the latest AWS innovation without any undifferentiated heavy lifting. And finally, we recognize that we have an opportunity to standardize the APIs that interact with AWS features and services, all the AWS features and services we talk about. And you may wonder, why is that? Firstly, today, as applications become increasingly sophisticated, builders need to work across several AWS and third-party services. Each of these services have distinct APIs that builders have to familiarize themselves with. While these APIs are descriptive and intuitive, some builders prefer a consistent set of APIs to manage cloud resources across various services. These builders who prefer a consistent set of APIs want to minimize the time it takes to author and maintain custom code to interface with the underlying services that are part of their application infrastructure. Furthermore, customers such as Steady and several others have outlined this need to standardize control plane APIs across AWS. We therefore came to the conclusion that we have an opportunity to offer standard APIs to interact with over hundreds of AWS and in some cases third-party services as well. To walk you through this in a little bit more detail, right? Like on the left-hand side of the screen, you notice that there are each service, each AWS service, be it Amazon EC2, AWS Lambda, or Amazon ECS, have service-specific APIs. Each of these APIs are unique in the sense that they have unique naming convention, input parameters, and corresponding resources, right? On the right-hand side of the screen, you see that to achieve a single workflow, for example, if I need to do a if I want to create a fully formed Kinesis stream, I have to stitch together several individual API calls to need this. Our question was, how can we use a consistent API method to interact with hundreds of AWS services? How can we unify this interaction across services, and how can we condense these workflow-based operations into fundamental units? So, to summarize, the three opportunities that lay in front of us were: can we support new AWS capabilities such as features and services closer to their launch or on the day of launch? Second, can we help partners such as yourself to simplify how you can integrate with the latest AWS innovation? And finally, can we standardize APIs to interact with hundreds of AWS services and along with third-party services? These opportunities led to the foundation for building Cloud Control API. Now, I'm going to hand this over to my colleague, Veli, who will introduce you all to Cloud Control API and discuss about how it addresses the opportunities we just identified and talk to you about the benefits of Cloud Control API.
Thanks again, Rahul. My name is Veli Xiao. I'm a Senior Partner Solution Architect at AWS. Let's talk about Cloud Control API. Cloud Control API is essentially a unified API that is designed to make it easier for developers to manage their cloud infrastructures and also to leverage the latest AWS innovation faster. And that's typically on the day of launch. It's offers a set of uniform API to manage the end-to-end lifecycle of your AWS resources. For example, using a single create command, I can create a Kinesis stream, IAM role, Lambda functions, or a CloudWatch log. And then using a single get command, I can describe all of the resources supported by the Cloud Control API. So let's dive deeper into that. You might wonder, how is this standard API works? Cloud Control API offers 5 set of resource-oriented APIs. That's including create, read, update, delete, and list resources. So this resource-specific API can operate on the supported resources. There are hundreds of AWS resources and also dozens of third-party resources. Resource includes set of attributes and also the handler logic that handle the API interactions with the underlying services. And all of these cloud control API supported resources comes with a standard schema and also response output and also the parameters and inputs. And then, while this standardized API is great, but then how does this actually help to address the customer's problem that Rahul mentioned earlier? And Cloud Control API address these problems. So let's start it. First, with the faster access to the feature and services. This works because Cloud Control API use the CloudFormation public registry to expose the resources built by the service team and also by the third-party resources. For a new AWS feature and services, these resources typically available on the day of launch or shortly afterwards. And then second, with unified interface, so these one-time integrations helps enable you to keep up with the pace of AWS innovations. Now you have one opportunity in here to develop a unified API code base using the common input verbs and also standard response and standard schema, and then do one-time integrations. So this is very important because with one-time integrations, you can potentially save hundreds of hours of annual recurring development efforts. And the third, with consistent API that is really designed to make it easy to manage your cloud infrastructures. Whether that is the Kinesis stream, CloudWatch log group, or Lambda functions, or hundreds of other resources that is supported by the Cloud Control API. And that's including the third-party resources as well. So to help you visualize the benefit of Cloud Control API and how it simplifies the interaction with underlying resources, let's take a look into that. First, at the base layers, you have the breadth services and deep functionality that AWS offers. Service teams and third-party build their resources that is onboarded into the CloudFormation public registry. And then Cloud Control API externalize this resource provider layer built by the AWS service team and the third party for the partners such as yourself to integrate with. For example, infrastructure as code tools such as Terraform by HashiCorp and also Pulumi are integrated with Cloud Control API. AWS toolkits such as JetBrains, Visual Studio Code, and Cloud9 are also integrated. You can also use Cloud Control API with the AWS SDK and also AWS CLI. And now you can have your own toolsets across CSPM, CMDB, cost management, observability, and many other use cases, and integrate with Cloud Control API and benefit from these one-time integrations. Now, I will show you the demo of how you can manage the lifecycle of resources using a Cloud Control API.
Okay, let's get started. In this demo, I will demonstrate the functionality of the Cloud Control API. First, we will create a new resource using Cloud Control API. I'll start with a simple example of a CloudWatch log group. If you're familiar with CloudWatch regular service API, you can see the immediate difference in here. I use the desired state to declare the new resource properties by following the resource type schema. In this case, there is a log group name and the retention day. Okay, now let's describe the resource I just created. Using the getResource command, I specify the type of resource and the identifier. So the point of interest of this output is the resource description sections in here, where I can find all of the properties of the log groups that I just created. With Cloud Control API, I can use the same getResource command to describe another resource, for example, a Lambda function. So same get resource command with the resource type of Lambda functions and the identifier of the Lambda function. Notice that the output is always consistent with the resource descriptions, identifier, and also the properties. Now to help to visualize this, with just a very simple JSON parsing, I can extract properties for both the log group and also the Lambda functions using the same command. So here's an example. This is my log group. And using the same get resource command, here is my Lambda functions. This allows me to build a single interaction or single integrations with Cloud Control API and use it to discover all supported resource properties in a consistent manner. Now, let's expand this idea a little bit. A typical use case for resource discovery is to list all available AWS resources and not just describing a single resource. Say if I have an EC2 instance, I use EC2 describe instance. I have Lambda functions, I use list functions. Log group, I use describe log groups. And these API commands are great for a granular control of how you want to list your resources, do filtering, paginations, and more. A Cloud Control API offers a single resource command or a list resource command that I can use to retrieve all supported resources. So list resource for a log group in this case. And then I retrieve all of the log groups in my accounts on this region. Same way for my Lambda function, use the same list resource with the type of Lambda functions. And then I retrieve all of the Lambda functions in my account. So building from the previous idea, using a single integration with Cloud Control API, I can list all of the Cloud Control supported resources and benefit from the uniform output. So when a new AWS resources introduced in the future, I can rely on the response or the output schema to retrieve the new resource. And I don't have to change the API command that I used to do that. So for use case of discovering AWS resources, this make it simpler because I can add the new resource type to the list and then do a scan, and then I don't have to change my toolsets. Now let's explore another unique feature of the Cloud Control API. Earlier, I showed you a simple example with the CloudWatch log group. Let's take another example. This time I want to create a Kinesis stream. After the stream is created, I want to assign the tag and then change the retention period. So when you need a fine-grained control to manage your AWS resources, service-specific API is perfect for that. So this is an example if I use a Kinesis API. I have fine-grained control to manage the resource state and when I want to introduce the new chains and set the resource properties accordingly. To achieve the same objective using a single atomic call with Cloud Control API, you can define all of these steps into the desired state. So here's another example of create resource with Kinesis stream, and all of the desired state include the retention period, shard count, and the tags. So Cloud Control API will asynchronously manage the interactions with the service-specific APIs. So there will be multiple back and forth API call that Cloud Control handles, and I can monitor the status and wait for this resource to be ready for use. Now, the atomic nature also comes when I wish to update the resource properties. Cloud Control API allows me to declare the update operations sequentially. So let's take another example. Let's say I have a requirements to update the CloudWatch log group retention period. But first I want to check if the existing value match to the values that I'm seeking for, and then update it accordingly. I can include both operations in a single atomic call by first specifying the test operations to evaluate, in this case, the retention period, if the value is 90 days. and then perform the replace operations, which is to change the retention periods into 180 days. So here's an example of that command, which include the patch document itself. So specify the update resource, the type of resource and the identifier, and the patch document that you saw earlier. Now, Cloud Control API will run this operation synchronously. The first operation is the test, and if it's a success, it runs the next operations, which is the replace. So notice in this case, I don't need to manage or monitor the set of the resource, whether the resource is ready for the next operations. Cloud Control API handles this for me. So Cloud Control API supports several operations as defined by the JSON patch RFC 16902. So that include add, remove, replace, move, copy, and also test. Okay, now we're almost at the end of my demo. Earlier, I also hinted about Cloud Control API interact with CloudFormation Public Registry extensions. CloudFormation Public Registry extensions include all extensions built by AWS and as well as third-party or AWS partners. Partner build their solutions and offer it as a public extension that customer can activate and use inside of CloudFormations. For example, AWS Quick Start team provides a reference EKS cluster resource type in the public registry. And this Quick Start EKS clusters offers additional configurations such as tagging, cluster logging, private endpoint, and more. I have activated this resource type earlier, so I can launch Quick Start EKS cluster just like how I interact with other AWS resources. Here's an example. I created a resource called AWS Quick Start EKS cluster with the desired state. So how does this work under the hood? Many AWS partners, such as yourself, have built their solution offering and published it to the CloudFormation public registry. Here's some example of that, including the Quick Start that I created earlier. And other example from other partners in here. A customer can activate these public extensions and then interact with the partner solutions using the Cloud Control API. So using the same 5 create, update, delete, read, and list API, partner and customers can manage these public extensions just like how they manage other AWS resources. So that's conclude my demo today for the Cloud Control API. I hope this demo gives you an overview of the capabilities of Cloud Control API and also spark ideas and how you could use it in your solutions. Next, I will hand it over back to Rahul, where he will tell the story of how AWS partners utilize Cloud Control API. So Rahul, I hand it over back to you.
That was an exciting demo, Veli. While we are hoping that you are jumping out of your seats after seeing the demo on the API consistency that Veli just talked to you about, we are sure you must be equally excited to hear about what all the integrating partners who have their solutions integrated with Cloud Control API are saying, and also learn about additional use cases for integration. So let's get straight into it. First, HashiCorp, as some of you are aware, provides a cloud infrastructure automation software that enables organizations to provision, secure, connect, and run infrastructure for any application. HashiCorp integrated their infrastructure as code tool, Terraform, with Cloud Control API to create the Terraform AWS Cloud Control Provider, which allows developers to use new AWS features and services as soon as they're available on Cloud Control API, which is typically on the day of launch. AWS Cloud Control API, in fact, makes it easier for HashiCorp's teams to build solutions to integrate with new and existing AWS services. Similarly, Pulumi is an infrastructure as code tool that allows developers to provision and manage resources using programming languages such as Python, TypeScript, .NET, and Go. And now with Pulumi's integration with Cloud Control API, customers can instantly access the latest Cloud Control API supported services and features as soon as they are launched without any delay or need for Pulumi to manually implement support. Pulumi integrated their infrastructure as code offering with Cloud Control API to create the Pulumi AWS native provider. And with using this provider, developers and infrastructure teams can now develop and ship modern applications faster and with more confidence than before. We are excited to share more use cases with you, and we would love to hear more on how you can help and have your solutions integrate with Cloud Control API. To walk you through the scenarios where this would be of great value to you, we're going to first talk to you about the consistent resource discovery using Cloud Control API. You can use the consistent list and read APIs to programmatically scan all the resources on behalf of our mutual customers and fetch the configuration state of those resources. Further, you can then apply your business logic to add value to our mutual customers. For example, uniform state management. What do we mean by that? Based on the business logic you recommend, our mutual customers can undertake specific actions on those underlying resources, such as aligning the resource configuration with best practices or enriching the metadata for those resource types. And finally, this opportunity is open for a variety of partner solutions and tools across cloud security posture management, configuration management, monitoring and observability, cost and resource optimization, infrastructure as code, among many others. As long as you have a tool that interacts with AWS's control plane APIs, you can benefit by integrating with Cloud Control API. So with this, I'm going to hand over to my colleague Veli, who is going to walk you through the getting started experience.
Thanks so much, Rahul. That is such an interesting story. We can't wait to see how you're going to utilize Cloud Control API. Here are some resources for you to get started. There's the product API pages that you can check out in here. Don't forget also to look at the blog posts. And if you want to get hands-on, of course, there is the API page resource and also the user guide. Thank you so much for joining with both myself and Rahul on these presentations. We hope that you find it useful and insightful. We always want to improve from this experience, so please take your time at the end of these presentations to fill in the survey as well. Thanks again, and let's go build and innovate on behalf of our joint customers.